Has the recording started, beta?
Yes, ma'am.
Okay, okay. Please start, beta.
Vibration and oscillation. Vibration is the to and fro or back and forth motion of an object. Vibration is also called oscillatory motion. The motion of the pendulum from one extreme position to the other extreme position and back is called an oscillation. A to B and back to A.
Okay. What is vibration? Vibration is that the body moves like this. The body moves like this, right? To and fro. It is
Yes.
going here, again it's going back, again it's coming up, again it's going back. So its vibration is what? It is leaving its central position and moving to and going back. So that is called as to and fro. For example, some people have got the habit of learning while moving in the hall. Have you observed that? They go back and forth. If they're thinking, they start moving. Yes or no? So what is that motion called as? It is to and fro motion or back and forth motion. Okay? So similarly, vibration is the to and fro or back and forth motion of any particular object. This vibration has got another name which is known as oscillation. So vibration is equal to oscillation. Let's take an example of a pendulum. This one. Okay? Now, from A to B, one move, and from B to A, this will be called as A to B, then B to A. That complete is called as one oscillation. You understood? Did you understand? So what is the extreme position? A and B. So first it will go from A to B and back from B to A. That complete duration, that complete movement is called as one oscillation. Did you understand better? Boys, can you hear me?
Yes, ma'am.
Yes? Okay. That's all. I hope you have understood. This is a motion of a simple pendulum. So you can see A and you can see B. So A to B and then B to A. So this is one oscillation. Now we'll see what is the frequency of sound wave.
Frequency of sound wave. The number of oscillation per second is called frequency. It is represented by the symbol Greek letter nu. The unit of frequency is
Hertz. Hertz.
hertz.
Hz. Okay. So something new that you are going to learn in this chapter is that what is frequency of sound wave? Number of oscillations per second. I already taught you what is oscillation. You have understood? Now we have to find out the number of oscillations per second. That is called as frequency. What is the symbol? It is nu. Nu. It's a Greek letter nu. This is how you have to write the frequency. The unit of this frequency is hertz or otherwise called as Hz. You have to remember all these things, okay? Okay, boys?
Yes, ma'am.
Now we come to time periods. This everything you have to remember. Frequency, time period, then how to use it in numericals. Everything you have to remember. Yes, better start.
The time taken for one oscillation is called time period. It is represented by the letter T. The SI unit is second. frequency, and time are represented as follows: T equal to 1 upon V.
No,
V
it is
for
new.
one
No,
oscillation.
it is new. Beta, I told you it is time period and frequency. B cannot
Yes,
come. B is velocity, isn't it? It is new.
yes.
Just now you read in the earlier slide. It is new. Okay, that is the new for one oscillation will be, say,
Nu is equal to 1 upon T.
exactly. So both of them are inversely proportional. So if T is equal, look over here, T is equal to 1 upon nu. So if I put nu here, so T has to go down, isn't it? So nu is equal to 1 upon T. What do you say? It is inversely proportional to each other. Now what is time period? For one oscillation, the time taken is called as time period. Letter T, capital T, is the time period. Unit is second, that is S. Now let's find out the relation between the frequency and time period. Just now I taught you that it is inversely proportional and hence it is T is equal to inversely proportional is 1 upon. If I call it directly proportional, then it should be T is equal to nu. If it is directly proportional, but it's not directly proportional. So what I will write? Inversely proportional to 1 upon nu. You understand? This is called as inversely proportional. You understood or not? So anything which is 1 upon is inversely proportional. Any problem, Beta?
No, ma'am.
No? Okay. Similarly, if t is equal to 1 upon nu, so I can very well put this nu here and put this t here. Can I do that? So this is what I get. Nu is equal to 1 upon t. Understood?
Yes, ma'am.
Yes, miss? Okay. So we had through the frequency and the time period. Now the third factor that we are going to learn is amplitude. What are you going to learn? Amplitude of sound wave. Yes, better.
The maximum displacement of an oscillating body from its central position is called amplitude, OB or OA, or the amplitude of sound wave is the height of the crest or tuft. It is represented by the letter A. The SI unit is the same as that of density or pressure.
Pressure. Okay, fine. So what is amplitude? If I say that oscillating body is making a wave, right? You know that this is oscillation. Now this is the central position. Now the maximum displacement will be this. You agree? This is the maximum displacement. You agree or not? From the
Yes,
central
ma'am.
position? Yes. Now this is amplitude. What is this beta? Say this is amplitude. Any problem?
No, ma'am.
Okay, fine. This much you have understood. Now this amplitude of sound wave is the height of crest or trough. Now this is crest. I'll show you. The ones on top is called as crest and one on bottom is called as trough. So these are trough and these are crest. Okay? So this is the maximum displacement. Can you see this? This is the maximum displacement. All these are amplitude. What are these beta? These are amplitude. So from the median, the upper portion is crest and the bottom portion is trough. What is the symbol? It is A. Amplitude is denoted by A. Okay. In between two crests, for example, you take this portion, It is called as wavelength. What it is called? Wavelength. Okay? And you can see over here, I will just highlight it. See, this portion is amplitude. What it is? What is beta? Amplitude.
Amplitude.
Okay? Look over here. Now here, OA is amplitude. OB is amplitude. You understood now? We saw with the help of wave formation. Now we are seeing with the help of pendulum. So what is amplitude over here? OA is the amplitude and OB is another amplitude. Yes? Back and forth motion, to and fro motion. What do you say? Boys, are you understanding or not?
Yes, ma'am.
Okay. Now we'll see what is the amplitude of sound. What does it depend on? Please.
Amplitude of sound. Number one, volume control. Number two, loudness. Number three, strength of the wave measured in dB decibels. Number four, energy of the wave.
The amplitude of sound depends on, for example, I will show you. If you whisper, it is absolutely 10 decibel. If you see the rustle of leaves due to wind, it is around 18. Waves on seashore will give you 40 decibels. Shouted conversation that you have generally, you will have 70 decibels. Vacuum cleaner make more sound, say around 80 decibels. Rock music make it 100. Jet engine, that is jet airways, the aeroplanes, it makes 110. And the pain that you get, that means it's so noisy that you cannot take it anymore. It's painful for you to take that. That is, say, 150. See, it's beyond. It's 150. Can you see this? So you can understand how the things are creating problems. The noise, if it is more, if it goes beyond a certain threshold, how could it be painful that you have observed now? It all depends on the volume. The sound is pleasant till a level, till a control. When it goes beyond that limit, it becomes noise. Do you agree with me? The sound is pleasant till one level, and it goes beyond that limit, it becomes painful, it becomes noisy. Yes? Hello? Yes? It is measured in decibels. It all depends upon the energy of the wave, and that creates uh, the loudness of the sound. We see now how sound travels. Please.
How sound travels. Sound passes through the medium as longitudinal waves. When the vibrations are fast, you hear a high pitch. When they are slow, you hear a low pitch.
How sound travels? Know that sound needs a medium, so it always passes through the medium. As what? As longitudinal waves. When you come in ninth standard, okay, you will be given more in detail. Right now, you're not supposed to work in detail for as transverse waves or longitudinal waves, but you should know that sound travels as longitudinal waves. That's the reason that I have taken it this slide. Now, when vibrations are very fast, we get high pitch. High pitch means like a whistle. When you blow a whistle, The sound that you get is of high pitch. If you speak softly to someone, that sound is of low pitch. I hope you have understood the difference between high pitch and low pitch. Yes, boys.
Yes, ma'am.
Look over here. You can see over here high pitch. Can you see this high pitch? Because they're so close to each other. And this is low pitch. They're far away from each other. Understood now? Got the
Yes,
difference? Now low sound and high sound. Please.
low sound and high sound. The pitch of sound, shrillness or flatness depends on the frequency of vibration. If the frequency is high, the sound has the high pitch, and if the frequency is low, the sound has low pitch.
The pitch of sound, that means it's very, very painful for ear. Let's call it shrillness. And softness, that is flatness, all depends upon the frequency of vibration. It all depends on the frequency of vibration. Now, if the frequency is high, obviously shrill, high pitch. If the frequency is low, the sound flat, low pitch. Now, did you get the relation between the frequency and the sound, the pitch of sound? Yes, boys.
Yes, ma'am.
Did you get the relation between the pitch of the sound and the frequency? High pitch,
Yes, sir.
high frequency, shrillness. Yes. Low
Yes, sir.
frequency, low pitch, flatness. Okay. See, you can see this. The amplitude is small. You see the frequency? The amplitude is small. Look at this. And here the amplitude is high. That's why it's got a high volume. Yes or no? Yes or no? You understood this now?
Yes, ma'am.
Amplitude is small over here in the low volume, whereas in the high volume, the amplitude is big as compared to, let's say, pressure. Okay? So what we have understood? Read. What we have understood, beta?
High pitch is equal to high frequency.
And
Low pitch is equal to low frequency.
now we have understood nicely that if you call it high pitch, what does it mean? High frequency. And if I say flatness, low pitch, we call it as low frequency. So it's directly related, the pitch and the frequency. The same thing in a different manner, we are going to learn loudness and pitch of sound.
Loudness and pitch of sound. Number 1. The loudness of sound depends upon the amplitude of vibration. If the amplitude is less, the sound is feeble. If the amplitude is more, the sound is loud. The unit of loudness is called
Decibel,
decibel. Number
dB.
2. The pitch of sound, shrillness or flatness, depends upon the frequency of vibration. If the frequency is less, the sound has low pitch. For example, sound of a drum, sound of an adult, etc. If the frequency is more, the sound has a high pitch. For example, sound of a whistle, sound of a baby.
So far, we had talked about the shrillness with the frequency. Agree? There's a
Yes,
relation
ma'am.
with it. No? Low pitch, low frequency, high pitch, high frequency. Yes? Now we are going to relate it with amplitude. Remember, we are going to relate it with amplitude. Amplitude is less, the sound is flat. Amplitude is more, the sound is loud. You understand? Again, the direct relation we have between the amplitude and the sound.
Yes, ma'am.
So loudness of sounds also depends on not only frequency, but it also depends on amplitude. So we say that if the amplitude is less, the sound is very weak, very soft, flat. And if the amplitude is more, the sound is very loud. And that we measure with the unit which is known as dB, decibel. Now we come to the pitch of sound. This was loudness of sound was due to amplitude. The pitch of sound is on to the frequency. Okay? So if the frequency is less, sound low pitch. Frequency is more, sound as high pitch. For example, the whistle sound, baby cries. Yeah, baby cries. Hello? Please put off your mic. Thank you. So whistle sound and when the baby cries, that sound is very painful. Remember that. It's unbearable at times because it hurts your ears, isn't it? So, see, this is a flat sound, drum. You can hear drum. But when you blow a whistle, you put your hand on your ears, isn't it? Because whistle sound is shrill, whereas drum sound is flat. It is loud, but it is flat. I hope you have understood the difference between the sounds. Yes? Hello? Boys, are you there?
Yes, ma'am.
Okay. Now, how sound travels to your ear? What you see over here, it is alarm bell. That's how you get up early in the morning, isn't it? So see, the alarm bell is dancing. Can you see this? So if it does not make sound, it will not reach your ear. So when it reaches your ear and then you get up, what happens? Please read.
The air vibrates but does not travel from the alarm to the ear.
What does that mean? Here our medium is air, but air is made up of particles, isn't it? Air is made up of particles. There are so many particles. What is happening actually? The sound energy is taken by this particle, but the particle is not reaching here. But what this particle is doing? This particle is giving the energy to the other particle. This one is giving energy to other particle. That's how it reaches. You getting it?
Yes,
The
ma'am.
particle is not moving, the energy is moving. What is moving, beta? The vibration is moving. The energy is moving. You understood now? So that's why
Yes.
this one is said that the air vibrates, but the air is not traveling. The energy is traveling with the vibration. The particle remains here. The particle will not reach here. The particles all remains at their own position. But what is traveling is the energy, is the vibration. You got it? Do you understand? So the energy
Yes,
is
ma'am.
going from one particle to another particle, and that's how it reaches our ears, and we get the energy, the sound energy, and when we get up. Okay? Now we see how what is inside in our ears, how human ears are made up of. Please.
Human ears. How we hear sound through our ears. Sound enters the ear through the ear canal It makes the eardrum to vibrate. The eardrum sends the vibration to the inner ear. From there, the signal go to the brain, and then we hear the sound.
How do we get the sound through our ears? Sound like I'm speaking. Right now I'm speaking and you were speaking so I can hear your sound, isn't it? How does it happen? We'll go one by one. This is the outer ear. Please, someone's mic is on, better. Check it. I'm getting my voice back. Thank you. Now see, this is the outer ear that is called as pinna. What is the other name of outer ear, beta? Pinna. Okay? Ear lobe that you call it as the thing which is on outer side is called as the outer ear. That is called as pinna. The sound collects and it goes inside the ear canal. Where is this going, beta? What is this? Ear canal. So sound is traveling through the ear canal. You agree? Hello?
Yes, ma'am.
Yes. So it is moving in the ear canal. Okay. The third one is there's an eardrum in the ear canal. So when the sound is traveling like waves, it hits the eardrum and the eardrum starts vibrating. Agree? Boys, 8th standard, do you agree?
Yes, ma'am.
Then from here, it goes to middle ear. Now, middle ear is made up of these three small bones. I will do the detailing in the next slide. There are three small bones which is making the middle ear. It goes over there. From there, it goes to inner ear. You see this? Inner ear. From inner ear, it goes to the auditory nerve. The auditory nerve reaches the brain, and the brain interprets that from where I'm getting the sound. What is the source of the sound? Is it clear?
Yes, ma'am.
More in detail. Read better.
Structure of the human ear. The outer ear called pinna collects the sound waves. The sound waves passes through the ear canal to a thin membrane called eardrum. The eardrum vibrates. The vibrations are amplified by the three bones of the middle ear called hammer, anvil, and stirrup. The middle ear then transmits the sound wave to the inner ear. In the inner ear, the sound waves are converted into electrical signals by the cochlea and sent to
Cochlea,
the
cochlea.
brain through the
Say it's cochlea.
cochlea, and sent to the brain through the auditory nerves. The brain then interprets the signal as sound.
So the outer ear, you saw this outer ear? This is outer ear. What is the other name, beta? What is the other name? Hello? What is the other name of the outer ear?
Pinna.
Pinna, exactly. Pinna. So outer ear is also called as pinna. Now we go to the second. So what is the function? It is collecting the sound waves. Then where does the sound wave goes, beta? It goes to the ear canal, right?
Yes, ma'am.
It goes to ear canal. One by one again. So I told you that we'll be revising it many a times. So it is going to the ear canal and then it hits the eardrum. It starts hitting the eardrum and the eardrum starts vibrating. This much have you understood? Have you understood this much?
Yes, ma'am.
So we have come to eardrum. This is the eardrum. This one. This is the eardrum in the ear canal. Okay. From here, the eardrum starts vibrating. You see this eardrum, what it does? It vibrates. The eardrum vibrates. Now, these vibrations are magnified or rather amplified by what? Let's see. The vibrations that you got at the eardrum are amplified by hammer, anvil, and stirrup. These are the three bones which is making the middle ear. And they are magnifying it. They're highlighting it or rather amplifying the sound that you actually got in the ear, in the ear canal, that is amplified, that is magnified three times more by the middle bone comprising of hammer, anvil, and stirrup. This much have you understood?
Yes, ma'am.
Okay. So now middle ear is over. This middle ear sends the sound waves, which is the amplified sound waves, to the inner ear. Can you see this inner ear, beta? Can you see this inner ear?
Yes, ma'am. See.
This one, which is known as cochlea. What is the name of the inner ear? This portion. It is known as cochlea. It looks like snail, isn't it? It is cochlea. What it is called as, beta? See. It is called as cochlea.
Cochlea.
So this is the inner ear. So from middle ear, it goes to the inner ear. What is the function of this inner ear? These sound waves, the magnified sound waves, are converted into electrical signals. Converted into electrical signals. Okay? And from there, it goes to this auditory nerves. What is it? Auditory nerves, which takes the signal, the electric signal, to the brain, and then the brain interprets the sound. Any problem? Any problem?
No, ma'am.
Okay, fine. So I think you have understood it nicely, clearly rather, the function of our ears, what is happening inside our ear. Yes?
Yes, ma'am.
Again, in a colorful manner, we are going to show you. The outer ear is pinna. You see this? The outer ear is pinna. Yes?
Pinna.
Then we have the ear canal. What we have, beta?
Ear
One by one
canal.
will show. Ear canal. We one by one will show. This is the
Ear canal.
ear canal. Then we have the eardrum. You see
Eardrum.
this? This one. We have
Yes,
the
ma'am.
eardrum. Then we have the middle ear. These are all bones, right? This one. The complete structure is the middle ear. From middle ear, it goes to inner ear, which is known as cochlea. What it is known, beta?
Cochlea.
Cochlea.
Inner ear.
Yes, inner ear. From here, it goes to the auditory nerve, which goes to, where does it go, beta?
Brain. Brain.
Things are clear now?
Yes,
So
ma'am.
many slides we did for human ears, isn't it? The things are very clear, line by line we have explained.
Yes, ma'am.
Yes? Okay. Yes, read.
Mobile phone use radio. Sound equal to electrical signal equal to radio signal is equal to
Not equal
electrical
to.
signal.
No, it is not equal to.
Ma'am.
Sound is converted to electrical signal, converted to radio signal. The radio signal converts to electrical signal, and then sound is released.
Yes.
The
Sound convert to
conversion, we are showing the conversion.
yes,
Okay?
ma'am. Sound convert to electrical signal, convert to radio signal, convert to electrical signal, convert to sound. In
Got
one
it?
phone, yes, ma'am. In one phone, the sound is changed into an electrical signal, then into a radio signal. In the second phone, the radio signal is changed into an electrical signal, then into sound.
So, what you see over here, this is mobile phones, right? You see this mobile phones? Now, in this one, the sound is changed into electrical signal, and then it changes to radio signal. Okay? And then this radio signal changes to electrical signal, and then that electrical signal changes to sound. This is how, when I'm talking in my cell phone and you are receiving my sound in your cell phone, this is what is happening. Got it? So, for example, in my phone, the sound that I'm speaking right now, hello boys, listen to me. What I'm speaking just now is the sound which is converted into electrical signal, and then this electrical signal is converted to radio signal, and that radio signal is picked up into electrical signal, and then it is converted to sound, and that you hear my sound in your mobile. Do you understand? That my sound that you get in your mobile, this is my mobile, this is my mobile, and this is yours mobile. And what is happening in between, you understood?
Yes, ma'am.
So my voice, that is sound, how does it change, beta? It changes to electrical signal.
Yes.
Electrical changes to radio signal. And then this radio signal in your phone. So your phone is catching that radio signal, that what I am sending. And that radio signal is changed to electrical signal, and that electric signal gets converted into sound that you receive from my end, that you are hearing right now as my sound. So much of conversion takes place before my sound reaches you. You can understand. It's a complicated process, remember. So, hope I think a bit you have understood how from one cell, from one mobile, how it is related to another mobile. Now, did you understand? How can you
Yes,
hear
ma'am.
my sound in your? Because my sound is changed into electrical signal, signal changes to radio signal, and then your mobile picks up that radio signal, changes to electrical signal, and then convert to sound. Hope things are clear.
Yes, ma'am.
Now see how telephones work. Please read.
Telephones. The message travels through miles of wires as an electrical signal.
So telephones, how does it work? So you can see this wires. Can you see this wire? So it
Yes,
is
ma'am.
carrying this electrical signals. So we have got lots of cables or wires, isn't it? Now, one is The microphone, the other one is loudspeaker. The one which you use, which you keep it near your mouth, is the microphone. And the one which you put it on your ear is the loudspeaker. Yes, you agree?
Yes, ma'am.
And we can hear each other's voice when we are miles off wires. The message is traveling. The wires are so long, they are almost miles long. And what is getting converted? Electric signal. My sound is getting converted into electrical signal. You understand?
Yes, ma'am.
So I think we come to a close of today's session. I hope you have understood nicely. I pray
Yes, ma'am.
that you have understood it. Okay, beta? So try to finish in this week. Well, how was the exam, by the way? You did not comment
So,
on it. Will you give me out of out? Everybody said so easy, but no one gives me out of out. So I wish this time you must have done well, better than before. Do I expect? Yes, beta?
yes, ma'am.
Fine. So please go through the uploaded video once again. If you find that you have some doubts or you have got some problems, just go through the uploaded video
Yes, ma'am.
and rectify yourself. Okay. Have a good day, beta. Bye.